Hello everyone, welcome back to lecture series on data structure. In this session, we'll continue implementing the linked list by adding the node at last. Now before we add the node at last, we have to check whether the list exists or not. So basically what we have is a global node, that is the head node, okay, which we have created by using a structure. In the previous session, we have created the node head, which is a pointer, and initially we had set that head to be null. Now whenever you are adding the node, whether you are adding at first or at the end or anywhere in between, what we have to check upon whether your head is null or not. So right now let us say we are focusing on adding the node at last. So very first thing what we'll do is that we'll check whether our head is null. So we'll go like this: if head equal to null. If head is a null, if head node is a null, that means list do not exist. So whatever the node we have created, that node will be the first node as well as the last node. Okay, so in that case, let us say we have created a temporary node called temp. So in this case, your head will be equal to temp. But in the case your head is not null, that means list exists. Let us say we are having the list something like this: 10 to 20, 20 to 30, 30 to 40. After 40 there is no element in the list, so next pointer of 40 will be null, and the head pointer of this list is pointing at 10. So let us say we have created the node a temp, and in that temp we have stored the value 50. So this is temp node, okay, in which we have stored the value 50, and the next node is null. What we want, basically we want to add this node in which we have stored the value 50 to the end of the list, that means after 40. So at the end, what we require our list to be something like this: 10 to 20, 20 to 30, 30 to 40. After 40 it should be 50, and the next point of 50 should to be null. So what we'll do in this list, let me copy this list, let me copy this completely and paste over here. Okay, so what we'll do over here, we'll create another dummy node, and let us say that dummy node is recognized as node n. Okay, so you are having the head which is pointing at 10. Also we'll create one dummy node called n, that n is also pointing to 10. Okay, now that n will be pointing to 10 when we'll say n is equal to head. Now we'll traverse this list from the head till the end of the list, and end of the list is identified when the next pointer is null. So we'll go like this: while next pointer of node n is not equal to null, you just move ahead. In the sense you can simply write n is equal to n next, because next is also a pointer. Okay, next is a pointer of type struct node. So at the end of this loop you will come across the last node where the next node is, or next pointer is null. So finally what you need to do is, whatever this n is there, okay, let me say over here, initially what we are having 10 to 20, 20 to 30, 30 to 40. So initially before this loop we are saying n equal to head, that means n is pointing to location 10. Now what we are saying, while next pointer of n not equal to null, you move ahead. So next pointer of 10 is 20, so we move ahead. The next pointer of 20, now n is at 20, now next pointer of 20 is not null, okay, it's pointing at 30, so move ahead. So now n is at 30. Now at 30 we are again checking the next pointer, is it null? No, so you move ahead. So now n is at 40. Now here we are checking whether the next pointer of n is null. Yes. So now at the end of the loop what will happen, now my n is at, or node n is at 40. So we have reached the end of the list. Okay, now after this while loop, what you have to specify that the next pointer of n now points to 50. That means it should go like this: 10 to 20, 20 to 30, 30 to 40, and at 10 we are 10 is identified by head, and the last node over here, that is node 40, it's now getting identified by node n. Now what should happen? The next pointer of n should point to temp, should point to node temp. Okay, so to get this, what we will say, n next equal to simply temp. So what happens? The next pointer of this n will point to temp. So in this, what we are having the value 50, and next pointer is null. So at the end of this, what we'll get the list something like this: 10 to 20, 20 to 30, 30 to 40. After 40, the next pointer of 40 is not null now, rather it is pointing to 50, and the next pointer is null over here of 50, and the head node is still at 10. So this is basically this is how we basically add the node at last. Okay, so we continue with the code. Okay, so let me open this Codelette over here. Okay, so this is the same program which we have created in the previous session while we are adding the node at first. So now what I do, I add one more node function over here to add the element at last. So void add at last. Okay, initially what we'll do, we'll create one temporary node. Okay, so struct node asterisk temp. Okay, same way as we created previously. Now you allocate the memory space. As it's a structure, you need to space as it's a pointer, you need to specify that it's a pointer of type structure, and you'll allocate the memory space by using malloc and specify the size of what is the size is of structure node, which is again a pointer. So this is how we basically allocate or occupy the space. Now after that, first you read the element to tell the user to enter the element, cout \n, enter the element, or let us say data or number, whatever you can say. Okay, we'll add this element to the variable x, or we'll assign that to variable x. So say in temp, to assign the member variable of the structure, we use hyphen and tag symbol x, and then we'll say next pointer of temp to be null. So now your temp node is initialized and value has been assigned, as well as the next pointer of temp is null. Now we want checking upon the operation of adding this node at the end. So very first thing, what we'll check if head is null. If head is null, if head is null, then whatever the that means the list is empty. Okay, so that means whatever the node we have created, that node will be the last node, first and last node. So we simply say head equal to temp. Else, in the case list exists, then what we'll do, we'll create another node, struct node, let us say n. Again, it's going to be a pointer. Now here we'll say n equal to head, because head exists. Now we'll check upon, no, not check upon, we will loop across till we reach end of the list by simply saying while n, next pointer of n is not equal to null. So while next pointer is not equal to null, you move ahead. That means simply saying n equal to n next. So at the end of this while loop, you are at the end of the loop where whose next pointer is null. Now here you should say next pointer of n is now pointing to temp, and that's it. Your list is created, or you have added that element at the end of the list. Okay, so now that's it for this function. Now we come upon our main method. Okay, we are having this method that we already discussed in the previous session. We won't look into that again, but now over here we'll change that this method. Now here, instead of adding the element at first, what we'll do, we'll call upon the method to add the element at last. I hope the function name is proper. Let me just cross check. Add at last, yes, it's proper. Now let's execute this. Let's compile. In the case for, we'll check upon any errors are there. No errors. Let me see. Yeah, no errors. Okay, one thing we missed out over here, we need to also keep on the count on number of nodes those are getting added. So what we'll do, whenever we are gonna call upon this method to add the node, whether at first or at last, we'll increment this counter. If you remember, we have created one counter called C. We initialize it to 0. This is a global counter. So this counter is getting increased both while adding the element at first as well as while adding the element at last. Now let's recompile and execute this. So we are calling upon the method add at last. This is your execution method, main method. So let's execute this. Okay, so here is the terminal. So it says add the element. Now let us say the element is 10. Then right now what happened, the list was empty, so we added the element 10. So it checked upon whether head is null. Yes, head was null. So whatever we added, that was the node value 10, that 10 became the head element. All right, then we are adding the value 20. Now, but now what's happening, head is not null. Okay, we are having some value over here. Let me rearrange this. Hold on. Can I reduce the font, or reducing font will do? Let me check. Yes. Okay, so now let it go this way. Now over here, so first we added 10. At that time node was head was null, so 10 became the head. All right. Then we added 20. Now as far as this logic is concerned, head is equal to null is false, so it's going into the else part. Okay, and we are moving at the end of the list. So basically what should happen, 20 should be at the end. So your list will be 10 to 20, after 20 null. Okay, then we add the next element. Let us say next element we are adding over here is 30, then 40, and then the last 50. That means now your list should be from your head is at 10, next pointer from 10 pointing to 20, the next pointer from 20 to pointing to 30, next pointer from 30 pointing to 40, and next pointer from 40 pointing to 50, and after that next point after 50 is nothing. That means we have nothing after 50, so it should be null. And what we are doing over here is, after you are done with this calling method or calling this method 5 times, we are calling upon this method. So our list should display as 10 to 20, 10, 20, 30, 40, and 50. So let's check with this. So I press enter over here. Yes, we get it. So this is basically how we add the element at the end. In the next session we'll look into how to add the elements in between. Okay, we'll discuss that in the next session. Thank you.